In this project, you'll use 3 buttons and 1 RGB LED and program them so that each button controls one color of the red, green, blue LED, turning it on if the button is pressed or turning it off if the button is released. Within the void setup function, you have 3 pin mode functions, one for each button. The first sets port 2 to an input pull-up, the second sets port 5 as an input pull-up, and the third sets port 8 as an input pull-up. When we use the input pull-up argument in the pin mode function, that means the program is going to listen for a signal from that port. Next, you'll use 3 pin mode functions to set each leg of the RGB LED as an output. So ports 11, 12, and 13 are all set as outputs, and that's where your RGB's shorter legs are going to be plugged in to your maker board. I like to think of the void loop as having 3 sections. One section for each button and color combination. This first section is an if-else statement that controls port 11 with button 2. The if statement has 2 parts. Between the parentheses is a condition that is checked every time the if statement runs. Between the curly braces is the actions that run if the condition is true. Here, you're checking to see, is the digital read of port 2 low? Meaning, is the button plugged into port 2 pressed? And when you're checking to see if 2 things are equal, you use the double equal sign. If that condition is true, the code between the curly braces will run, and here that's a digital write function with the arguments 11 and high. So it's going to send power to port 11, turning on the LED color of the RGB LED's leg that's plugged into port 11. Next, you have an else statement. The else statement has code between the curly braces that only runs if the if statement above its condition is false. So in this case, if the void loop checks port 2 and finds that it is not sending a low signal, the code will jump past the actions of the if statement and to the actions of the else statement. The actions of this else statement are to digital write port 11 low or turn off the LED color that's plugged into port 11. You can see in this program I left 2 blank lines in the code. That doesn't affect how the computer reads the code or how the code is run, but it does help me organize and separate the code in my mind. Like I mentioned, I see this as 3 different sections. So this second section is an if statement that controls port 12's RGB LED color with port 5's button. It looks almost exactly like the section that we have up above in the void loop. If the digital read of port 5 is low, then digital write 12 high, turning on that color of the RGB LED. Otherwise, if the digital read of port 5 is not low, then digital write 12 low, turning off that color. I have 2 more blank lines here to help me separate the third section of this void loop, which is another if-else statement. If the digital read of port 8 is low, then turn on the RGB LED color that is plugged in to port 13. Otherwise, turn off the port 13 and whichever color of the RGB LED is plugged in there. After this else statement, the code will reach the end of the void loop and it will jump back up to line 16 and start checking the if-else statements again. Although we have 3 if-else statements inside this void loop, you really can think of them as separate conditions, meaning that you can press down on button 2, button 5, and button 8, making all of these conditions true, and that means your void loop will run the code inside the curly braces of each if statement. So all of these conditions can be true, all of these conditions can be false, or any combination of those. Every time the void loop runs, it's going to check each condition in the if statement and either run the code inside the if statement's curly brace or run the code inside the associated else statements curly brace. These if-else statements act as a pair, so the program is only going to run the actions from one of them each time the conditions are checked.